Okay, good morning to all here. Greetings from Spain. Sorry, had a bit of cold, so my voice is a bit done. So welcome to this session about Kafka. Enrique Kafka is the Sad Kafka. I am Jose Enrique from Principal Software Engineering Coordinated by Singular. I've been working in this world about 16 years, more or less, and the leader of the open source initiative here in Coordinated by Singular. Our products, open source products, that's mainly important is the CalGene plugin, I will talk today for you, and several code generators based on APIs, the Sync APA and Open APA. So let's gonna start defining what is Kafka, because it's one of the main focus on this conference. So Kafka is a broker for stored message. The messages are events. The events are stored in as array of bytes. Every topic is split. Kafka is defined in topics. So you have like a tube that is called topic. So all the events or array of bytes is passed through these elements. It works well with domain-driven development and CQRS and some other interesting words. And it's a well-tested architecture. So it's made by LinkedIn and it's handled several million of messages per second. The improvement of this is you define the message that is passed through these topics as an schema. So you have a definition for the data that is stored in a place called schema registry. All this content was made by the Confluent, the main company that handled Kafka. But you also can use Epicurio or Google, or there are different schema registries now in the world, and have benefits and have some drawbacks. But let's define here. Kafka is extensively used. Is one of the most important message brokers in the world. Used by the 10 of 10 of the manufacturing, 7 of 10 of the banks, insurance company, telecoms. So it's more or less worldwide extended the use of Kafka. So, okay, here. Let's gonna define what is an schema. Okay. So an schema is an heterogeneous set of different types that based on the communication mechanisms. What does mean? You define the structure of the information that you are sharing between one point and another. So one element produces a message, other at the end of the topic, at the end of the communication, is consumed. So in order to keep these two guys understand each other, the message is defined following some kind of rules. Nowadays, the most important type of schema are those you can see here: the Apache Avro, the Json Schema one, and the Google Protobuff. Json Schema is mainly text-based, so it's a JSON that defines a JSON that is shared between elements. Apache Avro is also JSON-ish type of, but it's not. It defines a conversion at differentialization into some binary stuff. And the Google Protobuff is not based on JSON, it's more a text file that defines the message and the content. And then it extracts the data and send only binary data. So it's really useful if you have a high performance. You need highly performance in your system. So what you are gonna get from here? So here we'll be dealing with. So here, what you will developing solution where there are no one. We're dealing with complex problems and a new testing method for the Kafka infrastructure, meaning that at the moment, a part of our product, there is no way that you can generate data from inject into a Kafka. So if you don't provide data to a Kafka, Kafka feels sad. Kafka is a bit unuseful. So what happened if you don't test your infrastructure? Unexpected bugs can appear. Malformer Avro can show up, so you can produce the message in what way, and the consumer cannot deserialize. So that means a focus of problems. Another type of thing that can happen. So it's a long way in order to test an even architecture. So we have been before. We need to focus on what is important, building high quality software solutions in order to provide the specific answers to our customers. So we build Color Gene. Okay. So a bit of context. We were involved into a migration from a monolith to an event sourcing or microservice architecture, meaning that we have a huge big software, and then you needed to split it in several microservices, all of them use an event source architecture. So our customer choose Kafka in order to handle all the message, and use Avro in order to provide some kind of consolidation between the producer and the consuming message. Something like that. So it's more or less a small diagram what we can find. So we have a site microservice that consumes the catalog, and also have a checkout microservice that made the reservation of the product. We have some reporting tools. We handle some product orders in order to that has been bought by our customers. We communicate with the fulfillment centers. We have some managed product that is used for the stock management in order to define this available for the catalog, and blah 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 blah. So you can see all the lines and all the craziness that we can find here. So all this infrastructure need to be tested. So we already did that, and we found several mines, and we don't have you to deal with. So what we found is that we have Kafka services between some of them. Other were using REST, other was using gRPC, and you still need to test all the communication between all the different microservices. Okay. So which was the state of the art in this moment? We are alone. There are some half-baked solutions around the world, but there is no Avro support, there was no Json Schema support, and absolutely no Protobuff support. So what did we need? We need to inject the data into a Kafka cluster. We need to generate data based on different schemas in order to test our business logic and also our performance, how our microservices works under stress. We need to define constraints for this data in order to test our business logic. We need to interact with the full system, not only Kafka but also REST, gRPC, GMS, and databases as well. So in order to test the full system, we need to test all the different communication mechanisms and databases that is in this architecture. Okay. It needs to be as generic as possible in order to keep low maintenance effort, meaning that we don't want to make specific products that are attached to a specific solution in order to avoid keeping duplicated projects, one for solve the problem itself, another one in order to test these microservices. So if we have 20 microservices in our system, we don't want to have 20 other microservices in order to test all of this. We need to avoid to be bound to a single project. So following all these points, we need to found something. So we are engineers. There was no solution on site, so we made one. Key point for our solution: need to support a connection to an schema registry to retrieve the different schemas in order to process them and allow to define the constraints. Okay, here. In order to define the constraints to generate the data, And also we need to support loading a file to produce the data in case you want to test new schemas before go to production or before getting to the system. You can test your specific changes in order to see how the system works. So having that as our main point, we build our solution. It was not piece of cake. So it was really complex solution. We have to deal with infinite use cases. I mean, how complex can be the object that you have to use in your real world can be almost impossible to imagine. So we can have complex objects with objects inside objects, with arrays inside arrays, with maps of arrays. And believe it or not, we found those kind of situation in our world. We need to deal with the Protobuff support that is not as easy as expected because we need to generate data dynamically in order to match unknown schemas. So we need to create and handle uh, schemas that are defined to create the Java classes in one moment and not to generate dynamically this send of data. And we need to deal with null and optional data. So you can have an schema that can support null values, or you need to generate data that with from a schema that maybe not all the fields are required. So in order to test properly your system, we need to generate data with all the required fields and also support generate or not some specific fields if they are mainly optional. So we have a documentation of our wiki, so you can go there. Here is the URL in the bottom and take a look about how the things are handled. We have a sequence support, so you can generate data based on a sequence. You can define the start number on this sequence will start counting. So not only from 1 or 1,000 or 3,000, whatever number you want. We have also a sequence of elements, so you can define a list of names or a list of values, and we will iterate over them. When the list is ended, we go back to the start and start keep going. If you generate, let's say, 1 million messages, and you have only a list of 5 names, we will be iterating with these 5 names, go back to the start and keep going. And we need to maintain the difference between schemas. So not all the schemas define the same things. Okay, they define the basic data, integers, names, strings, and so, but some of them have more restriction than others. So JSON schema, you can define restrictions for top and lower values, but in average you can do it. So we need to handle all of this. So are you ready for the demo? Let's gonna see how it works. Let me try to get up from here. So I think you can see this is a JMeter screen. So basically what we made some kind of components you can see here. Okay. All of those are provided in our plugin. So from the start, we have the connection to our schema registry. Here you can set up, define the okay. So here you can configure the communication and the security configuration for access to this schema registry. If you test the schema registry, here you can see that it has been successful contact to the schema registry at the URL blah blah blah, and you can find that there is 4 subjects in this registry. Here you can define the configure the strategy that we use to resolve the subject and the topic. So one thing I didn't tell you, is when you have a Kafka with several topics and you can send message between those topics, Kafka itself, it allows to send whatever thing because it's only handle array of byte. They don't care what is inside. It's your responsibility to define that which is in this topic in order to the consumer to handle it. So you can allow to use to produce whatever message there, and the customer will need to handle it. Or if you use an schema registry, there is some strategy. So based on the topic or based on the schema, it resolves that only this schema can go to this topic. So the customer will receive only the data that it can deserialize. Okay. Here we support several serializers based on Protobuff, based on Json Schema, Protobuff serializer. We have our own, and we are supporting the Confluent base, the Confluent ones. The different our serializers, they don't need to handle a schema registry. We mainly created in order to support Avro identify and generate the data. If you are using a schema registry, then you can use the Kafka Avro. It will connect to the schema registry and work as a normal producer. Here you can see the different topics that we are generated, the subjects, sorry. So we have here the events, and we have here some based on the topic element. Those are used for the consumer part. Okay, and here we can see is the schema that we are used to generate. So here we have the fields of the schema, the types, the definition of the timestamp, and here we can set up the values. In this case, we are generating an account number that is a counter made by the generate using the JMeter random tool or counter. We can use our own, so there is no problem for that. But in order to you to say how it integrate with the JMeter, I use a variable from the system. Okay. Hi, Jagoda. And here we can see the Kafka producer options. So here we define the Bootstrap server URL. If we're using Zookeeper, we will put here the address. Honestly, it's not necessary, so you can leave it as is. It will handle it without no problem. The topic name where we are injecting the data, and all of these are the different values that you can pass to the producer. Those are documented in the producer properly. Is not handled by us. We only make a pass through from these values to the producer. So we are working with, let's say, some GIS security. You need to enable, and you put here the file, or you put here the text with the credentials in order to authenticate with the Kafka. Okay. Here we have another function that generates another account number. So here we have an account, and here we have a random number. Same producer, I mean, same component in order to generate the bank movements. Well, here is like a bank simulator, so we have bank accounts and bank movements. And here what we have is here we have the value about the account number, the movement, deposit or withdraw, and the amount that will be generated randomly totally, and the dates. One point for you to see is we have defined here an enum value. This enum value have two values, deposit or withdraw, so it will appear here. If this enum have more values, it will appear here in the list. If you want to generate only one of them, just come here and remove it, and only will generate the deposits. Okay. And as I told you before, here we only have Jose as a main guy. So let's put Jose, let's put Lucas, let's put Jagoda. So here will appear all these names in the data I generated, and we also have a consumer. So connected to this topic and the same Kafka server, we will consume the data that is generated by my demo application, okay? So here we are generate during 60 seconds. Let's gonna put a bit less, 10 seconds. 8 threads with 10 seconds of ramp. Let's gonna put 2 seconds. So we are generating about eight different bank accounts per second. You can put here more, but I don't want to burn my laptop. It's really high consuming. Here we will have 4 threads with, let's wanna put 10 seconds, and we will generate about 4,000 movements. Okay, and here we will have 10 threads during 100 times. It will consume all the message that we generated. Here in this component, we will see which is generated or which is consumed. So cross fingers, all this should work right now. If we press the play, the data is generated. As you can see here, we can see the data is generated, some with Jose, some with Jagoda, some with Gukash. So all the data is generated because they are amount. This is the creation of the bank account. The amount is 0, but the movements, it should have some random number. So you can check it. The amount is absolutely random. We only have generating deposits, okay? And the consumer should have the new amount for the maybe the software is failing, but at the moment it's only generating my message. That is weird. Okay, maybe we have some problem here. Oh yes, I know what happened. From previous steps, I have my database, it hasn't been cleaned. So here we can see, sorry, all the account that has been created. So we are using Mongo here in order to back up the data. And here, I don't know why it's complaining today. Demo problems. I think it's kind of weird that it's failing now, but here we can see the data has been generated, amount has been changed from the previous test. The data is here, the movements are also stored in the database. This is for the previous one, so we have the withdraw. The data is all random, okay? The account number should match that one we have here, maybe because the data is random, so more or less we should have a 22 accounts somewhere. Yes, and the amount has changed. Here, okay, maybe if I toggle this and toggle that, and I increase this one to 100, I can get all the message that I just create right now before. Yes, here we can see that the amount is changing, still not, so need to consume more. In some moment it should appear the ones that it just generate. For Jagoda and Gukesh. But maybe not, they are not allowed to have money in the bank. Okay, that is a shame for me. So now if you want to use it, it's really easy to make. So it's a fast and easy process. You have two choices. You can clone the GitHub repository, or you can download it from the Maven repository. It's published there. You can build the plugin following the instruction and drop it in your JMeter installation directory. You just download the jar and drop it there and have fun. What happens if you have, damn it, if you have a complex Avro? Oh shit. There is no such thing as a complex Avro or Protobuff or Json Schema. We almost handle all the possible situations. Of course, there are some that maybe are not totally covered, but if you find something that you need to support, just open as a ticket so we can use it. We support complex structure, okay. We also have sequence types, shit. Sequence types and IT types, as I told you before. So the sequence generates a unique numeric sequence per field, and the IT types use the data from the array that we saw before, and it generates the data from there. So next steps, we have some projects in the oven. Hopefully we will be able to show it in the next conference if we're invited to. So thank you for all, guys. This is all. Any questions? No questions? Looks like there is no questions here. Okay. Do you have solutions for integrate Avro with Logstash? Not at the moment, but if you open as a ticket, we can work on it. It is something that we can do it in our plugin. Of course, we will do it. Anything? Any more questions? Okay, thank you for have the patience to listen me, and sorry for all the problems in this presentation. Hopefully, I will be better the next time. Thank you for seeing it. I think no more questions, so we can keep going. Okay, thank you guys. Pleasure to be talking here. Have a nice day. Bye bye.